Looking today at the index laws extended. Now, I'm not giving you new laws as such, but I just want to show you how we can use expressions and simplify them to be able to solve problems. Okay, so if we're given a times b, or an expression in brackets, all to the power of m, we can write it obviously as ab to the power of m, but what that means is we can split the terms. So this really means that a is being put to the power of m and b is also being put to the power of m. Okay, that helps us to be able to then simplify it, the expression, if we're given other terms as well. Okay, similarly, if we're given a over b in a fraction, we can write them separately. All right, so a over b all to the power of m means we have a to the power of m over b to the power of m. But obviously there b cannot be 0, okay, because we cannot have 0 on the bottom of a fraction. All right, so if we have a look at our examples that I've got for you today, we'll put them into action. So we've got 5b all to the power of 3. So what that means is 5 is being put to the power of 3 and b is also being put to the power of 3. So in its simplest form, we would evaluate 5 to the power of 3, which is 125, b to the power of 3. Okay, so it's just getting rid of those brackets and writing the expression in the simplest form possible, which is always our aim. Okay, then we've got 4 outside of c squared, d cubed, all to the power of 5. Okay, so you notice the 4 has been not put to any power, so it's going to stay as is. And then we have our power of a power rule. So what we really got is 4c squared to the power of 5 and d cubed to the power of 5. So that's just showing you separating those terms, okay? And then we're going to simplify that using power of a power. So we've got 4c to the power of 10, d to the power of 15, okay? In fraction form, all right, we've got 6 over b all to the power of 3. We can separate those. So we've got 6 to the power of 3 over b to the power of 3. Okay, 6 to the power of 3 is 216 over b to the power of 3. Okay, so it's just about evaluating number values where possible, okay, to give us the simplest form of our expression. All right, so then we have a more complex example that's going to use a combination of our laws. Now, don't feel like you have to try and get the simplest form possible in one step. That is how you're going to make mistakes and end up with the wrong answer, okay? Just take it step by step. Yes, you might use a bit of extra room, but being careful reduces the risk of making mistakes, okay? So we'll separate what we've got here. So we've got x squared y cubed over c all to the power of 3 multiplied by xc over y all to the power of 4. So I'm just going to look at my first term here, and I'm going to separate. So I've got x squared, and I've got that to the power of 3. And then I've got y to the power of 3 also to the power of 3, okay, all over c to the power of 3 as well, okay. And I'm so that's my first set of brackets, and then I'm multiplying that by xc over y all to the power of 4, which separating gives x to the power of 4, c to the power of 4 over y to the power of 4. Now we can start to clean this up a little bit. All right, so we'll just clean up our first fraction so that our top is going to end up being 2 times 3 gives us 6, so x to the power of 6, y to the power of 9, because 3 times 3 gives us 9, over c to the power of 3. Multiplied by, now there's no cleaning up we can do in our second fraction, so we're just going to rewrite that. X to the 4, c to the 4, all over y to the 4. Okay, now we can start to use our index laws. We're going to use our index laws for multiplication and combine these two fractions. Okay, so we'll go straight across the top. We've got x to the 6 times x to the 4. That gives us x to the 10 because 6 plus 4 is 10. Y to the power of 9 times c to the power of 4. Nothing matches there, so we're just going to write those out. Y to the 9, c to the 4. Okay, notice I'm just spacing it out a little bit so it's quite clear what my values there are, or my terms there are. And on the bottom, we've got c to the power of 3, y to the power of 4. Okay, now we can start cleaning this fraction up. Okay, I've got x to the 10, y to the 9, c to the 4, all over c to the 3, y to the 4. You'll notice I don't have any x's in my denominator, so all my x's are going to stay up the top. So I've got x to the power of 10. All right, and I've got y to the power of 9 in the numerator, y to the power of 4 in the denominator. So 9 minus 4 is going to give us 5. So because I've ended up with a positive number, that goes on the top. And c to the power of 4 over c to the power of 3. 4 minus 3 is 1. Remember, when we have 1 as our power, it is simply just the pronominal, which is c. Okay, so hopefully that clears it up. And if you're not sure, watch it again and see what I'm doing, particularly with this last one. It is quite complex. We are using a lot of simplifying, okay, but hopefully I've stepped it out so that it's quite clear what I'm doing in each step, and I'm not trying to skip and make it happen quickly. Okay, I know it can be annoying to write stuff out, but sometimes it's necessary. Give this video a thumbs up if you found it helpful. Remember to subscribe to my channel, and you can get notified when I upload new videos.